Energy. Energy. When you play for a long time, you feel tired. It means your ability of playing is reduced. Why is your ability reduced? This is because you have done some work in playing and you have used your energy to do that work. So, energy is the ability to do work. 1. Energy is defined as capacity to do work. Let us take one example to understand it more clearly. To cut a log of wood, we have to raise the axe vertically upward, and some work has to be done in raising the axe. If the axe is now allowed to fall on wood, it can do work in cutting the wood. Thus, the work done in raising the axe has been stored up in it, giving it the ability for doing work. 2. Energy can be measured in terms of work done. The amount of energy possessed by a body is equal to the amount of work it can do when its energy is released. Unit of energy. Energy and work are directly related to each other and are mutually convertible. So, the units of work and energy are the same. The SI unit of energy is joule, J. The energy required to do 1 joule of work is called 1 joule energy. Bigger unit of energy. Sometimes, bigger unit of energy is used, which is kilojoule. The symbol is kJ. Now, 1 kilojoule is equal to 1000 joules. Energy can also be measured in calories. 1 calorie is the amount of energy required to raise the temperature of 1 gram of water by 1 degree Celsius. 1 calorie is approximately equal to 4.2 joules. 1 calorie is equal to 4.2 joules. Do you know? A 60-watt light bulb uses 60 joules of electrical energy every second. Different forms of energy. There are different forms of energy. Mechanical energy. Energy by virtue of which some mechanical work is done is called mechanical energy. It has 2 forms. 1. Kinetic energy. 2. Potential energy. 1. Kinetic energy. The energy possessed by a body due to its motion is called kinetic energy. A moving car, an arrow shot from a bow, a player throwing a ball, all these are the examples of kinetic energy. The water flowing in a river and a high-speed bullet possess kinetic energy. A swinging pendulum also possesses kinetic energy. The kinetic energy of a body depends on the following. 1. Mass of the body. 2. Speed with which the body moves. Its formula can be given as kinetic energy is equal to 1 by 2 mv square. M is equal to mass of the object. V is equal to velocity of the object. Ke is equal to kinetic energy. If the mass of a body is more, it will have more kinetic energy. For example, if a car and a scooter move with the same speed, car will possess greater kinetic energy because of its heavy mass body. Similarly, greater the speed of a body, more will be its kinetic energy. If the speed of a body is doubled, its kinetic energy will increase by 2 into 2 or 4 times. If the speed of a body is halved, then its kinetic energy becomes 1/4. Activity. Take 1 lighter and 1 heavier hammers. Strike both the hammers one by one on the iron nail fixed on a wooden board. What do you observe? The nail penetrates deeper into the board when the heavier hammer strikes the nail. So, we can conclude that the kinetic energy of moving heavier hammer is more than that of lighter hammer. So, the amount of kinetic energy depends on the mass of the moving object. Activity. Take a carom board and place a few carom coins on it. Hit these coins with the help of a plastic striker. The coins move to some distance due to the force applied by the striker. Now, push the striker again with a greater force. You will find that striker moves rapidly and hits the coin. As a result, the coins move at a greater distance. So, we can conclude that kinetic energy depends on the speed of an object. 2. Potential energy. The energy possessed by a body due to its position is called its potential energy. The energy stored in a body is also called its potential energy. Examples: 1. An object placed at a rooftop of a home possesses potential energy. 2. Water stored in overhead water tank possesses potential energy. Activity. Take a catapult. Put a stone in the rubber loop and stretch it. The moment you release it, the stone will shoot out with high speed. This shows that energy stored in the catapult is transferred to the stone and it moved very fast. Scientist. Sir Benjamin Thompson, Count Rumford, was an Anglo-American physicist and inventor whose challenges to establish physical theory were part of the 19th century revolution in thermodynamics. He also served as a colonel in the Loyalist forces in America during the American Revolutionary War. Rumford had observed the frictional heat generated by boring cannon at the arsenal in Munich. Rumford immersed a cannon barrel in water and arranged for a specially blunted boring tool. He showed that the water could be boiled within roughly 2.5 hours, and that the supply of frictional heat was seemingly exhaustible. Fact: up to 97% of the fuel nuclear reactor can be recycled into fresh fuel and reused. The potential energy of a body depends on the following: 1. Mass of the body. 2. Its height from the Earth's surface. 3. Acceleration due to gravity. Potential energy is equal to m into g into h. M is equal to mass, h is equal to height, g is equal to acceleration due to gravity. If a body is kept at a greater height, its potential energy will be more. If two bodies of different masses are kept at the same height, body with greater mass will have more potential energy. Sound energy. Sound is a form of energy which makes us hear. Sound energy is produced by vibrations of an object. All vibrations may not produce sound. When a whistle is blown, it produces vibration and we are able to hear the sound. When sound waves strike the ear membrane, it begins to vibrate and produces a sensation of hearing. If you strike a drum, its membrane vibrates and produces a sound. If you strike the drum harder, the membrane vibrates with a greater amplitude. As a result, a louder sound is heard. Thus, loudness of sound depends on the energy associated with it. Heat energy. Heat is a form of energy. It is also called thermal energy. A steam engine works with the help of heat energy to pull a heavy train. Heat energy can be produced in many ways. It can be produced by burning fuels or by passing electricity through different appliances. The food we eat is digested and it results in the liberation of heat energy. Heat energy is extensively used for various purposes. It is used to cook our food, to boil water, to keep ourselves warm in winters, etc. Light energy. Light is a form of energy which produces the sensation of vision. It enables us to see objects around us. Light energy from the sun is an important source to sustain life on the earth because plants prepare their food in the presence of the sunlight during the process of photosynthesis. Solar cells can convert the light energy from the sun into electrical energy. It is also required for the recording of images in a photographic film. Electrical energy. Electrical energy is one of the most useful forms of energy. Electrical energy is obtained by generators and dynamos. It is used in devices like heaters and ovens to produce heat. It is also used in lighting bulbs. Some objects use it to produce motion, such as electric fans. Chemical energy. The energy stored in a matter and is available for work through chemical processes is called chemical energy. The food we eat breaks into small particles during the process of digestion, and the chemical energy is released, which we use in performing various activities. Coal, kerosene oil, and electric cell have chemical energy stored in them. Fuels liberate energy when they are burned. This energy is utilized to drive vehicles and in machinery. Magnetic energy. When a magnet attracts a magnetic substance like iron, the energy used in this process is called magnetic energy. It is due to this energy that magnets can attract all magnetic substances. Iron scraps are separated from waste material using electromagnetic energy. Nuclear energy. A high amount of energy is liberated when the nucleus, central part of a heavy atom, splits or when two nuclei of different atoms fuse together. Heavy substances like uranium releases a very high energy when its atomic nucleus splits. The energy obtained from a nucleus split is called nuclear energy. It is used to generate electricity. This energy is also being used in the medical field, such as treatment of cancer. Law of conservation of energy. It states that the total energy of an isolated system remains constant. It means energy neither can be destroyed nor created. It transforms from one form to another. Real-world examples. 1. Water can produce electricity. Water falls from the sky, converting potential energy to kinetic energy. This energy is used to rotate the turbine of a generator to produce electricity. 2. When playing pool, the cue ball is shot at a stationary 8 balls. The cue ball has energy. When the cue ball hits the 8 balls, the energy transfers from the cue ball to 8 balls, sending the 8 balls into motion. The cue ball loses energy because the energy has been transferred to the 8 balls. So, the cue ball slows down, but the total energy remains constant. 3. When a moving car hits a parked car and causes the parked car to move, energy is transferred from the moving car to the parked car. 4. Fingers hitting piano keys transfer energy from the player's hand to the keys.